One more where I want to say let's prove that the limit, now I'm going to look at as x goes to 2 of this function 1 over x minus 2 squared equals positive infinity. This has a vertical asymptote at positive 2, and they both go up to positive infinity. So this definition said, what did this definition say? This definition said for any m that's greater than 0, there is delta greater than 0. So f of x, I'm not going to write f of x, I'm going to write my actual function, 1 over x minus 2 squared is greater than capital M whenever 0 is less than x minus 2 is less than delta. So again, I'm going to start with this thing right here, 1 over x minus 2 squared is greater than m. And I want to work on that until I can get something with a x minus 2 in it. Okay, so 1 over x, I see an x minus 2. I'm going to multiply both sides by x minus 2 squared so that those denominators cancel. And I get 1 is greater than m over x minus 2 squared. And I'll divide by m. And that gives me 1 over m is less than x minus 2 squared. And then I'm going to take the square root of this to get just x minus 2. And when I do that, I get the square root of 1 over m is greater than x minus 2. But really, I think I'm doing some stuff that I shouldn't be doing there, because this was supposed to be plus or minus, and I'm getting a little bit confused. But oh, yes. So technically what I can do is I can say, if I take the absolute value back here, then when I take the absolute value there, then when I take the absolute value, that just makes it positive, and I get x minus 2, and then square root of 1 over m, because it's positive or negative, I get just the positive square root. And then if I rearrange these to put the absolute value of x minus 2 in the beginning, I get square root of 1 over m. And so that means that I'm going to let delta equal, because delta was what that square root, or that absolute value of x minus 2 was, I'm going to let delta equal the square root of 1 over m. So whenever someone says, hey, I want something where m is 10, you can say, oh, okay, go ahead and let your delta be the square root of, well, let's 1 over 10. Or if they say, no, I want a bigger m, I want 100, you say, okay, I'll let delta be square root of 1 over 100, which is not a square root at all. I could simplify that to 1/10. Or if they want m to be 400, you can say the delta is square root over 1 over 400, and that's 1 over 200. So that's how you do these proofs. And now finally, to prove that the limit of 1 over x minus 2 squared is infinity as x approaches 2, from our scratch work on the last slide, we had that delta was going to equal 1 over the square root of m. And so what I'll do is I'll say, given any m greater than 0 for my proof, let delta equal 1 over the square root of m, so that whenever the absolute value of x minus 2 is between 0 and delta, then we have the function 1 over x minus 2 squared is going to be greater than 1 over delta squared, because again, like x minus 2 was less than delta, so 1 over x minus 2 is going to be greater than 1 over delta. And 1 over delta squared, well, I said delta was 1 over the square root of m, so 1 over the square root of m squared. That's 1 over m, and this seems like the last one, and I get m. So essentially the function 1 over x minus 2 squared is greater than m to clean that up. And that completes the proof.